Next problem, if n1 of t and n2 of t are two independent Poisson processes with parameters lambda 1 and lambda 2 respectively, show that probability of n1 of t equal to k given that conditional probability of n1t plus n2t equal to n, which is equal to nck p power k q power n minus k, where p is equal to lambda 1 by lambda 1 plus lambda 2 and q is equal to lambda 2 by lambda 1 plus lambda 2. We know the Poisson distribution e power minus lambda t lambda power n by n factorial, that is equation number 1. Now we are using conditional probability. So probability of n1 of t equal to k given that conditional probability n1 of t plus n2 of t equal to n. So we are using that same formula. Probability of a given b is equal to probability of a into probability of intersection probability of b given divided by probability of b, a given b. So probability of n1 t equal to k into n1 plus n2 of t equal to n divided by probability of n1 plus n2 equal to n. So probability of n1 equal to k and n2 equal to n minus k. So conditional probability, so k is less than n. So the same idea we are using here. This is the law, conditional probability law, and n2 equal to n minus k divided by probability of n1t plus n2t equal to n. So probability of n1 equal to k intersection n2 equal to n minus k divided by probability of n1 plus n2 equal to n. So k and n minus k are independent, that is n1 and n2 are also independent, that is given. So probability of n1 equal to k into probability of n2 equal to n minus k divided by probability of n1 plus n2 equal to n. So we are using distribution function from 1. So substituting the values, first one they are given the parameter for the first one n1. The parameter is for n1 parameter is lambda 1, n2 the parameter is lambda 2. We are using e power minus lambda 1t power k factorial, e power minus lambda 2t lambda 2t power n minus k factorial divided by e power minus lambda 1 plus lambda 2t lambda 1 plus lambda 2t power n by n factorial. Reversing the denominator, so lambda factorial will come to the numerator. In the numerator there is denominator k factorial and n minus k factorial. We are bringing down that k factorial n minus k factorial into, so numerator we are grouping the numerator e power terms, e power minus common, t common, so lambda 1 plus lambda 2 into t, balance you are having lambda 1 t power k lambda 2 t power n minus k. In denominator as it is e power minus lambda 1 plus lambda 2 t lambda 1 plus lambda 2 t power n, e power minus lambda 1 plus lambda 2, numerator and denominator the terms are get cancelled. So we will get nck lambda 1 power k t power k lambda 2 power n minus k t power n minus, we are splitting the powers each and every term. So down lambda 1 plus lambda 2 power n t power n, so which is equal to nck lambda power 1 power k t power k lambda 2 power n minus k t power n, we are splitting t power n minus k t power n into t power minus k. Down we are having lambda 1 plus lambda 2 power n t power n and t power n, numerator and denominator get cancelled. So we will get nck lambda 1 power k lambda 2 power n minus k. In numerator you are having t power k into t power minus k get cancelled divided by lambda 1 plus lambda 2 power k into lambda 1 plus lambda 2 power n minus k, because in numerator you are having lambda 1 power k lambda 2 power n minus k, right? In denominator lambda 1 plus lambda 2 power n, lambda 1 plus lambda 2, right, power n So we'll get t lambda 1 plus lambda 2 power n minus k into lambda 1 plus lambda 2 power k, correct. So nck lambda 1 by lambda 1 plus lambda 2 into k, we are splitting power k, lambda 2 by lambda 1 plus lambda 2 power n minus k. So nck p power k q power n minus k, where p is equal to lambda 1 by lambda 1 plus 2 and q is equal to lambda 2 by lambda 1 plus lambda 2. That's all.